Okay, so engineering fundamentals. How I learned to stop worrying and love my life as a code monkey. If anybody gets the reference, I will be delighted and surprised. Other than Mary, she already got it. Let's see. So, a little bit about me. Who am I? Why do you care? So I've been programming for better than 3 decades at this point. I've been doing this full time for about 2. My dad was a programmer, so, which I think is likely to be the truth for a lot of you, but at my age, it's a little rare. I grew up with computers. My first programs were little batch files so I could save scum rogue. If you don't know what that means, it's fine. If you do, then you know. I've used a modem that was so slow I could type faster than it could transmit. Just imagine that, just pure text that you could send that that you could type in faster than the modem could go. And now, me in video, theoretically at 4K, if my camera could do it, going to a whole bunch of you, just easy. It's beautiful. Progress is wonderful. Engineers make progress happen. So, what is engineering? An engineer can do for $1 what any fool can do with 2. Great saying from one of the guys who just put railroads everywhere. And that tells us a bunch of things about engineering. It means math is important, obviously, but also money is important. Engineers have to work to a budget, and they have to optimize for money. They have to make sure that their businesses are profitable. People matter. It's not just that you're this guy, but you have to work with the guy who's handing you the dollar, the people who are making the thing that you have designed, the people who want the thing. All are people that matter to the result. Therefore, knowing how to talk to people and inspire people really matters. And it's about reality. It's what actually gets done. If you want pure, pristine, absolute things, that's what mathematics is for, or logic. Pi is 3.14159 dot 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 dot. But if I'm an engineer, 3.14159 is enough, because that's what, 7 digits? That's more accurate than any measurement I'm likely to be able to make ever. So if I can't measure the difference, who cares? At least from an engineering point of view. So, as you might have guessed, engineering is about trade-offs. You can never be perfect. All you can do is be good. So don't try to be perfect and fail. Try to be very good and succeed. They're about its budgets, its schedules, its value. Back in the 50s, there were people making toasters that would get the bread the exact same brownness every single time. And they did it with a wonderful feedback mechanism, and it's really neat how the engineering behind how they did it. And nowadays, your toaster probably, if it's the first one, it comes out a little lighter than the second one, which comes out a little lighter because the toaster heats up and the bread gets a little bit darker. And that's fine, because people don't care about the bread being perfectly exact. They do care about the fact that instead of being $100 in the 50s, it's $15 in the 2020s. So it's a much better value, even if it's not really as good of a product. So, for everybody, audience participation question number 1, which should be a poll. What kinds of trade-offs do you think are important when you're building a bridge? Okay, we'll give it another minute. Okay, anybody else? We've got most of you, but not everybody. Okay. So, looks like pretty good selection. Yeah. For those of you who didn't guess, the answer was all of them. Yes, even style versus substance. A beautiful, stylistic, artistic bridge that takes 45 minutes to cross is not useful. But a bridge that's boring is boring. Looking good, it can be important. Making something to inspire people, making something to just make their life that little bit better during their daily commute can be nice. Oh, I haven't shared the results. I'm sorry. I'm not quite used to doing webinars. So, yeah, pretty good selection. There we go. Okay. Okay, so engineering deliverables. When engineers make things, they tend to have two sort of types of deliverables. They have big individual single outputs. A skyscraper, a bridge, a a design for a toaster, or they might have more of a continuous output of deliverables, like a chemical factory. There's chemicals coming in all the time, and you're producing the output chemicals all the time, and both are important and both are significant. The big difference is, how do you approach it? When you've got a single output, you have to spend a lot of effort to make sure that that one output is going to be just perfect. If you are doing a continuous output, it's all about measure and test. Now, oh, the humidity's a little higher today, so I guess we'll have to turn up the voltage on the evaporators so that whatever chemical we're doing will evaporate off a little bit more quickly. Or it's particularly cold today, so this reaction is going to take a bit longer than it usually does. Maybe we should add a little catalyst. It's understand, cycle, feedback, and just continuously trying to get it right. And just getting that little bit more better every single day. So, audience participation question number 2. In software engineering, which a lot of you are here to talk about and learn about, what kind of deliverables do we tend to have? Okay, lots of good votes. Loving it. Okay, Okay, I'll give it another 30 seconds or so. Okay. So it seems like most of you have figured out that I like trick questions. The answer is, of course, all three. Sometimes it is single products, sometimes it's a continuous stream, and it's definitely more complicated than a simple this or that dichotomy. Single products. Back in the old days, you would ship Microsoft Word 7, and it would come in a box, and that was the box, and the CD that was inside the box was the product, and that was the single product, and that was all you got. And before the internet, you couldn't, if you made a mistake, it was there forever. You couldn't send patches. Nowadays, a lot of times it's a continuous stream. I can update a website 5 times a day with a small team of programmers, and that's every single 4 or 5 times a day we'll adjusting this or that detail of the website, turning this knob up, adding this feature, whatever. And that's just a continuous stream of tiny little deliverables. And the answer is, most of the time it's somewhere in between. When you produce a game, you ship a game and you ship it on a CD for some people, and you have the consoles, but there's almost always a day 1 patch with a whole bunch of fixes, and then another patch a couple weeks later, and another patch after that, and for years. And so you get this stream of patches. So it's not really one single product, but it's not a continuous stream. There could be weeks or months between the patches. So it's many single products, and everywhere it's all a mix. But it's more looking like it's become more and more of a continuous stream over time, and probably will continue to do so, because with the internet and connectivity having gone up so much, it's easier. Okay. So there's in engineering, there is something called the professional engineer. And this is a person who is tested and vetted and accomplished. In many states, it is actually illegal to call yourself an engineer if you are not a professional engineer. Professional engineers are a lot like lawyers. They have to take a specific exam that is the same for everyone, and then another exam that is specialized to their subject. For lawyers, it's specialized to the state. For engineers, it's specialized to the type. But you still have to take that base exam, and you will have to know how to build a bridge and a chemical plant and a car if you want to pass that basic exam. And then in addition to that, they'll start going into great depth in whatever particular aspect of chemistry you're in. And the reason why that is important is because a professional engineer is required to certify that certain types of things are safe. So if you ever actually go out to a bridge, even a dinky one that crosses a stream, or the Golden Gate Bridge, if you look around, there'll be a plaque somewhere with a guy's name and the date that the bridge was built. And that guy's name will be the professional engineer who took an actual physical special stamp, just like notaries have, and stamped the plans and said, I am a professional engineer, and I am saying that this design is safe and will be effective, and therefore I am responsible for it, period. And that means that there is legal liability associated with that statement. And it's a big deal. And that's why professional engineers are impressive and software engineers aren't. There are a handful of software professional engineers in existence, mostly in Texas, pretty much all of them having worked on the space shuttle, because that's the only place it's been required. And I think that's going to change, and I definitely think it should change. And you should just be aware of this as a thing that exists and might start to become important. Because I didn't learn about this in college at all. It was never mentioned, because for most programmers, it's just completely irrelevant. But we have computers in pacemakers now. We have computers in, the pump that is, treating cancer patients. I've worked on 2 of those. And there was no certified professional engineer who went and stamped anything about those from the software point of view. There was a professional engineer on the physical design of it, the actual pumping mechanism, but on the software side, there wasn't. And I don't think that's going to stay. I think that's going to have to change sometime. Yeah. So it's something to be aware of. It's something that I think is really worth doing. So, talking about bridges, which we've done a few times, if you had a hypothetical bridge, obviously we want it to be cheap, but this bridge needs to be very, very long. And we've got two different groups who want to build the bridge. One guy wants to build the bridge with these gigantic 30-foot trusses that will be rock solid, completely awesome, but it's going to cost $11 million, which is a heck of a lot of money, and even more so back when this bridge was being built. There's another guy who just finished the Golden Gate Bridge, that epic bridge you've probably seen in a bunch of film and TV. It is incredibly impressive, especially in person. Do see it if you can. And he says, I can use the same techniques I did for the Golden Gate Bridge. I can use these 10-foot girders. They'll be much cheaper. I can do this bridge for $8 million. And you're in charge of a project. It's obvious. $8 million, a guy who just finished an incredibly famous bridge. What could go wrong? Well, audience participation question number 3. As the bridge was being built, it started to rock a little bit, and shake a little bit, and it gained the nickname Galloping Goaty, because the girders would flex up and down while the bridge was being built. And what are you going to do about that? You're in charge of the bridge project. Okay, lots of people, lots of you are very quick off the mark. I love it. Okay. Awesome. I'll give it another minute or 2. Wow, highest audience participation yet. I love this. This is beautiful. Great. Keep voting. Okay. We'll call it here. So every single one of you had the same idea, which is pretty great. Every single person said, adjust the plans, add some stabilizing weights, but keep going with what you've got. And in fact, that's exactly what the engineer did at the time. So your instinct is exactly what his was. And that's pretty cool. Here's what happened. I got this from YouTube. It's supposed to be public domain. Yeah, not the greatest stout. And there it is, Galloping Goaty. You can see it flex and twist. How'd you like to drive over that bridge? Does that look particularly fun to cross? Yeah, I didn't think so. See how much movement is happening? That's a giant steel cable, or a bunch of steel cables woven together. Yeah. That car has a dog in it that was locked in when his owner went away. The dog couldn't get out. One of our participants asked, is this real? Yes, this is the Tacoma Narrows Bridge. You can Google it. It's an incredibly famous engineering disaster. They did exactly what I said. They went with the cheaper option, using the exact same design as the Golden Gate Bridge. But here, the winds were higher. And that design, when you look at it, it's the very first time that lift, aerodynamic lift, became a significant engineering factor in a bridge. Basically, that bridge became a giant wing. And when the wind would gust, it would lift up a bit, and then the gust would die down, and it would go back to normal and then down a little further because springs. And then the wind would hit it again, and it would lift up a little bit more. And they got into this, and the frequency of the wind gusts hit the natural frequency of the bridge. And so it just kept getting bigger and bigger and bigger. And that's what happens when engineers are working with something and they leave something out, or something that didn't used to matter. I mean, if you think of a Roman bridge, giant stone arched constructions, monstrosities, those never cared about lift. Wind running through one of those bridges? No, it would never matter. But as steel got more and more strong, as bridges got lighter and lighter because of it, yeah, the fact that bridges are basically gigantic wings started to matter. And they didn't take it into account. And that's how people get killed. In this case, no one died, except the dog. Oh, okay. So yeah, on that, a slightly lighter note. So I want to introduce the basic idea of the taxonomy, and so I'll do that by talking about the taxonomy of cooks. So, you're all familiar with basic cooking. You've got, the person who, can barely boil water successfully, and are just terrible cooks. You've got, you know, your favorite grandma who makes you the most delicious dinners ever, and you just love going over her house because she always has fresh baked cookies. Or maybe you don't. I didn't, sadly. But a lot of people have that experience. You have those really good home cooks who make delicious things. You have the guy just working in the kitchen, doing his job, making decent food for people. Maybe it's a diner that serves, steak and eggs and a couple of different meals, and is does pancakes and eggs and bacon and a few other things. Nice good old greasy spoon. Or you have the family restaurant, that Italian place that does pizza and pasta, and it's really good, and lots of fun to visit. And you've got the fancy restaurants, the Michelin stars, and $100 a plate, and really incredibly tasty single bites of food. And then you have the food chemists, the people who design microwave dinners that then the people who barely can boil water will put in the microwave and hit go. And hey, it's quick, it's easy, it doesn't take time. I love them. And these are all different types of cooks. Some of them are engineers, like the guy who designs, the person who designs, exactly how to, how much turkey and how much cranberries to put in a turkey dinner instant meal, because you needed the right water content and the right everything. And that there's a whole bunch of math and a whole bunch of engineering that goes into that. But not everybody who cooks is an engineer, nor should they be. If you're going to take your grandma's favorite recipe and turn it into some mass marketed, can of baked beans, say, then you probably want to hire one of those food engineers to figure out, well, how stable is it going to be? How long will it last on the shelf? What can we tweak about this recipe to make it cheaper? And that they're going to be able to do that for you. But you also need grandma to come up with the recipe in the first place, and to experiment and to make you love that kind of food. So that's sort of so the taxonomy is categories, groups of similar things. And now that we've talked about the taxonomy of cooks, let's talk about the taxonomy of software people. As was mentioned repeatedly in the keynote, there are lots of different types of people involved in software, and not all of them are engineers, and they shouldn't be. And so we've got the standard developer, we've got the guy who's tweaking the website, the person who's tweaking the website to get the perfect set of colors so that people's eyes pay attention to the things that are important and can sort of gloss over the stuff that's less important. You've got the people who know exactly what the right font for any particular thing is and how to vary it when this particular thing is really important. So do we want to use a different font for that, or just bold, or maybe italics? There's a person in most companies that answers those sorts of questions, because they can be incredibly important. They're not an engineer, but they're still highly paid, and they're still very important. And when you need someone like that, you need someone who has that specific specialized knowledge. And you have the salespeople. I mean, and the marketing people. If you have the best product in the world, but no one knows it exists, you're out of business. If you have the best, even if everybody knows it exists, if nobody is taking orders, you're out of business. A business needs really good engineers and really good engineering and really good marketing and really good sales and really good everything else. And they don't just need engineers. They also need, the person who does fonts and design, and the person who does user experience, who says, okay, well, you've got 15 buttons all jumbled together here. That's confusing to people. Let's sort it out and make it nice and regular and standardized so that that people can find the right button that they want very easily. That's an incredibly useful person to have. And there's the person who does, who does database work, the DBA, who knows all sorts about how to investigate when you can't get your data quickly enough, can figure out how to speed it up, can do all sorts of amazing things, but they have no idea how a user interface works because it just doesn't matter to them. And all of these are important, and they're all good. And you can be more than one. But you want to know what you are, you want to know what other people are, and what they can do, and how they can help you. Because, if you ask a DBA, which font should I use? The answer will be, I don't know. If you ask a graphic designer, how should I index this table in order to make queries faster? They're not going to have a clue. Right person for the right job. And you can be several of these. You can be one of these. Everything's fine, but you should be aware of this and be cognizant of it. Pay attention to it. If you want to fit several niches, that's great. If you want to fit one niche really, really well, that's great. I'm more of a generalist myself, but sometimes that means that sometimes I need a specialist. I can diagnose simple database issues, but there are plenty of database issues where I just have to shrug and go over and ask a DBA for help. And that's fine. I can do most of the work, and sometimes I need a specialist. So, the application of general engineering to software engineering. People. Good programmers are so important. Good managers are even more so. Money. If, I've worked at a bunch of different startups. All of them have failed. I've been unlucky. But that happens. And the reason that happened was we ran out of money. There's a budget. People trying to be perfect are going to sometimes cause problems. Don't. And pay attention to ethics. It matters. You have the power to kill people with programming and with other engineering. Don't. Unless you're working for the Defense Department, in which case, well, please don't, but you probably will have to. Professional ethics is something that a lot of people don't think about, but most programming can be used for good and for bad. We have all sorts of stories about how people are abusing social media. We have all sorts of stories about, all the wonderful things that people put on the internet and then get hacked. Well, guess what? Making things hack resistant is part of your job. And if you don't do it, you're not doing a good job. And being lazy being unprofessional is unethical. Have morals, know them, use them, love them. So now I'm throwing it open to any questions that people have about this, about anything. We have one question from one of the slides that I missed at the time. The question being, so basically, it's illegal to call yourself an engineer in some states unless you are a professional engineer. Yes. Some states, unless you have that specific license and the stamp and the insurance and the liability and the professional associations and all the stuff that goes with it, if you call yourself an engineer, you are breaking the law. It's not that many states, and software engineer is often considered an unofficial exception, which I don't like. That's my personal opinion. Not everyone agrees with me. Lots of questions about the bridge and is that really wobbling? It was the Tacoma Narrows Bridge. It is related to the Golden Gate Bridge in that it is the same engineer built it using the same basic design. The reason why the Golden Gate Bridge didn't collapse in the exact same way is that the wind patterns are different. It's literally just the wind is different. He got lucky the first time. Second time, he didn't get lucky. Mary, would you be willing to type in the chat the actual spelling of Tacoma Narrows?
Sure, yeah, I'll do that.
Thanks. Actually, I can go back. This picture was here for a reason. And is that my cat in the picture? Yes, it is. He is about 9 months old. His name is Saffron. He is an awesome kitty. I would show him to you, but he's not around right now because I closed my office because I didn't want him jumping in and bothering us in the middle of the talk because he would absolutely love to do that. How can it wobble that much when it looks like cement? It was cement and steel. The cement was on the Godos. So if we go back to the video, I'll see if I can find the right spot. Okay, so that you see how there's I-beams going vertically up and down, supporting the road, and then underneath that is some giant block. That giant block is the 45-ton anchor weight that they decided to add to each of the trusses on the bridge, hoping to damp down this particular problem while they were building it. It obviously didn't work. And it is steel and cement, but if you look at it right, it's also a gigantic wing. And when you have a wing that big and the wind's hitting it just right, there's something called specific frequencies, and you'll learn about them if you ever take more advanced physics. And basically, it starts wobbling just a little bit back and forth. And every time it starts to wobble, it starts to move again, it gets hit and starts wobbling just a little bit more. Think of it like when you're on a swing set. You know, you're on a swing set. If somebody pushes you at just the right second, you start going a little faster, and then a little faster, and then a little faster. You know, right as you get to the top of your swing, somebody gives you a little push, you go a bit higher the next round. And if the wind was basically just pushing it at the exact right time for a few hours, and it was actually doing it for days. It was a couple of months, I think, that it took for the metal fatigue to get so severe that the bridge actually failed. The question is, did the cement not dry properly, or was it not constructed properly? The cement was completely fine. It was constructed exactly to the plan. The plan didn't account for the wind. The wind lifting up the bridge and pushing it over, because it had never mattered before. I mean, why would you think about aerodynamic lift, you know, the stuff that keeps an airplane in the air, when you're talking about bridges? Until you start making the bridges very, very light, because, you know, steel is not light, but compared to, you know, 10 feet of stone, steel's pretty light. Was the bridge rebuilt after this incident into a more and stronger bridge? Yes, it was. You can go and see it now. Why didn't the cement break sooner? Luck, safety factor. When you're an engineer, you always want, if you tell people don't go over this bridge unless your truck weighs less than 16 tons, then you make sure that it can handle 20, 25 tons, just because, it might start rusting a little bit. It might not be maintained quite properly. Your calculations might be a little off. Somebody might make a small mistake in construction. You have a safety factor. The safety factor kept the Tacoma Narrows Bridge up for a couple of months, till it didn't. But shouldn't they consider the wind? Yes, they should, and now they do. But it had never mattered before, and that often happens in everything. People have been building bridges the exact same way for thousands of years, and for thousands of years, wind didn't matter much until suddenly, we get new composite steels, we get new industry, better manufacturing techniques, and suddenly, suddenly it gets light enough that yes, it does matter. And like I said, engineers were really good engineers working on this bridge. Yes, very good engineers. I mean, the guy got the Golden Gate Bridge first, and that's not a contract you can get if you aren't pretty well known as being a good engineer. That's an incredibly famous bridge. Where is this bridge? Tacoma Narrows is Oregon? I forget. Let's see if it says back on this opening picture. Oregon, Washington. Doesn't say. But I think that's I think that mountain's reasonably famous. I didn't think to look. So yeah.
I just looked it up. It's in Washington. It says Puget Sound in Pierce County, Washington.
Thank you. Okay, we have a few minutes left. Let's see. That's Mount Rainier. Thank you very much. Okay. So, quick, just some very general life advice that I have. It's more complicated than that. Any explanation you get for anything, you can always come back with it's more complicated than that, and because it's always true. This is an iPhone. Okay, this is an iPhone. I dropped the iPhone. Okay. Now, what happened? We can talk about the physics of it and how it accelerates, and then we can add air resistance, and then we can talk about how it bounces, and then we can talk about how the bouncing made some sound, and how that creating that sound lost energy, and therefore it didn't bounce as high. And then you can talk about internal friction and thermal energy, and talk about the fact that it's not a perfectly ideal spring, because nothing ever is. And then talk about conservation of angular momentum and all the conservation laws. And you can keep going down that rat hole until you get to physics that literally no one knows, but we have a couple theories. And that's just dropping an iPhone. From dropping an iPhone, you can get to a discussion of the most advanced physics anyone in the world has, because it's always more complicated than that. So anytime somebody tries to give you a simple answer, ask them why a few times, because whatever you're talking about, it's a bit more complicated than that. In life, have a plan and be ready to throw it away. Something will always go wrong with your plan, but you still need to have one, because you'll be able to keep half of it, 3/4, a good chunk. And that part is great. So you have a plan for most of what happened, and then you just improvise the rest. Learn how to learn. Different people learn differently. Some people learn best by taking physical notes. Some people learn by hearing it. Some people learn by doing it. Some people only learn if they have a motivation to learn. Figure out how you can learn best and use that. Think critically. Everyone is trying to do something for a reason. I'm doing this so that I will have better people to work with in the future, and so that I can feel good about myself. Understand people's motivations, understand why people have motivations. Also, I'm doing this because I get the rest of the day off, which is a pretty nice bonus. If you don't, understand how to take an argument and break it down into its pieces and analyze them, and then put it back together and decide whether that argument has merit or not. Understand trade-offs. They're everywhere in life. Value your time. In general, if you take your yearly salary and divide by 1,000, that's how much it costs every hour for for whatever company you're working for to keep you employed. Roughly, rule of thumb. And so, ask yourself, is what I'm doing right now really worth that much money to the company? And can my boss really justify paying my salary based on what I'm doing? And hopefully the answer is yes. And if it isn't, talk to your boss and figure out how to make the answer yes. Because at some point, somebody's going to say, hey, we need to cut spending. And you want to make sure your boss has the best possible argument why you shouldn't be part of that cut. Impostor syndrome. Everybody will have a day or two at least where they feel like, oh God, I'm surrounded by such smart people. They can't possibly know how stupid I really am. Everybody feels that way, at least sometimes. And some people feel it a lot. And it's normal to feel that way. Your emotions are important, but they are wrong sometimes. Everybody's felt imposter syndrome. Everybody will feel imposter syndrome. So if you have it, don't, feel it, acknowledge that it exists, but don't feel that it's correct. Talk to your boss, talk to a friend, talk to a mentor, and understand that, okay, this is a feeling you have. It is not necessarily a true statement about the world. And along those lines, mental health is just as important as physical health. If your pancreas is working a little weirdly, your doctor gives you insulin. If your brain is working a little weirdly and the chemicals aren't quite the same, then the doctor will give you a different pill. And that's fine. Pay attention to it. Everyone goes through bad patches, a bad breakup, a horrible day at work, got rear-ended, whatever. At some point in your life, you will be in a position where you could benefit from some therapy. Go and get it. Sometimes that therapy can be crying on a friend's shoulder, but sometimes you need more than that or different than that. Go and get it. Almost every company has, nowadays in tech, has a 1-800 number you can call and just talk to somebody and vent and get it out of your system and feel better. Use it. They're already paying for it, whether you use it or not. So use it. Get the benefit out of it. And finally, jokes will exist. I wish they wouldn't. I wish all jokes would go away, except, oh wait, sometimes I'm a joke, so maybe not. Anytime you get more than about 4 or 5 people in a room, somebody's going to be a joke about something. It's just part of life. That said, you do not have to accept severe jokiness. If somebody is really pushing, talk to your boss, talk to HR, talk to whoever, pay attention, and take good notes. Because bad companies will often do horrible things when people speak up. Good companies will look at it, will resolve it, will deal with it. And if your company isn't one of those good companies, do they really deserve having you working there? You are a valuable person, no matter what. Even if you drop out of high school and are working construction, you are a valuable person. You are a human being. You are a sentient person. You matter. You should be treated with respect and dignity, period. Doubly so if you're costing the company $200,000 a year to keep in there. And remember, that's not just your salary, that's also your insurance, the lights, the space you take up in the building, the computer you have, all of that. So, you know, if the company's investing a lot of time and money into you, they have an incentive to keep you happy. Make them do it. So that's all I have. There's no more questions, and you've got 3 minutes to get to your next one. So I guess the timing worked out pretty well. Thank you all for coming. Thank you everybody who participated in the group participations. Hopefully you had some good ideas. Feel free to look me up on LinkedIn and ask me whatever. Thank you all so much. Hopefully I was useful. There'll probably be some sort of survey that you'll be getting. Please do answer it. Goodbye, and enjoy the rest of your day.
Thank you, Owen, for sharing all of your advice with everybody. Goodbye, everyone.
Oh, yes, and sessions have been recorded, and I am stopping recording now.